Welcome everyone. In this course we will study the HAP software, which is one of the most powerful tools for calculating buildings, cooling and heating loads, in addition to the energy modeling. The hourly analysis program is provided by Carrier, the leading vendor in the HVAC field for more than 1 century so far. Actually, I used to utilize this HAP during my early years since it was under DOS version and was called as E20. We will learn in this HAP course how to set up a project in HAP no matter the size of the project, how to construct the layers of the walls or roof in HAP, how to create a proper schedule that can enhance your energy saving, how to add load parameters for any space including fresh air, equipment, people, lighting, partition, etc. and how to cross-reference any of these parameters for precise calculation and to effectively succeed in a review process for your design. How to make global changes to all spaces in one function, how to create a system to get the capacity of the individual equipment and the overall plant capacity as well. In spite of all what I have just mentioned, I presume this should be common among all well-prepared HAP courses. Then what's special about this course? Allow me explore with you some of the reasons. First of all, here I'm offering you 17 years of experience. You will scarcely have such a chance in any online course, either in the engineering field or any other. With dozens of variant types of mega and small projects and almost 2 decades of experience in this field since my graduation 2004, worked for top listed firms worldwide, I supervised tens of engineers from different cultures, different countries, newbies and experienced ones. That's why I feel your needs and know exactly what you are looking for in this course. Reason number 2 is why, not what. It's not a matter of only how to use the software, but the core idea is why. I checked many of the courses and I astonished when lecturers say, here we add this number or that certain value. Excuse me, what? This is long far away from the proper engineering mentality. As an engineer, you have to understand why every single value is being added and what's the magnitude of its impact. This is exactly what I am offering here, in addition, of course, the explanation of how to use the software itself. The next reason is technical basics are explained. If you are either a fresh graduate or not even a mechanical engineer, don't worry. The major concepts are explained to ensure your full awareness of the concepts, explaining the refrigeration cycle and its components in the different HVAC equipment without complications nor sophisticated scientific words, explaining also the load components and how to reflect them in the software, providing a case study small building with revealing about 10 different possible options of how to serve such with various HVAC equipment and systems. Then how to reflect each one of them in the software. Then most of application types are explained. Although our project here is a multi-purpose building, but of course it doesn't cover all kinds of applications. Actually, no project can. That's why I added in this course a dedicated section to explain separately vast varieties of applications types, such as office buildings, residential, kitchen, restaurants application, toilets, industrial, medical, including operation and patient rooms, commercial malls, substations, data center, etc. Then it comes one of the major sections also for tips and tricks. Along this whole length period in this field, I still find tens of experienced engineers who are being tricked by some certain cases when they try to apply the practical cases into the software. That's why I assigned a dedicated section for this particular topic. Let's see some of the examples that this topic includes. One example is related to the fresh air connections. What's the proper type of connections? Free above the false ceiling, direct to the fan coil unit plenum, or direct to the space itself? What is the proper temperature for each case? How to perform air balance in each case? Which one we should use in the design and why? How can the information being added to the HAP, either for the supplying FAHU or for the receiving FCU or AHU? This is one example. Another example is condensation. This is also a very tricky topic. When the condensation is expected to happen, how this can be determined, Can we provide non-treated fresh air safely without causing condensation inside the air-conditioned space? Is it safe to provide supply slot diffusers near to the glass facade to terminate the external heat source from the sun just before spreading into the space? Or condensation is expected on such hot surface? Hence, is it better to provide return air outlets in such area instead? What are the governing factors? All of these we will discuss it in this course. One other example is related to the sizing of the chiller plant. Shall we consider sum of peaks or peak of summations? The meaning of each term and differences with examples are explained also in this course. Moreover, in this section you will find the answer to some other tricky questions, as why fan coil unit capacity in the plant sometimes equal to the ones in the system, while some other times are double the value. Yes, such vast variance. Why in some cases we may change the height of the space up to 5 times or even more without no impact on the results. On the other hand, this can be dramatically impacting the load. Also, why the weather conditions of the projects are suitable for sizing all equipment except the FAHUs, which require in some cases changing the entire weather condition to calculate them only, and many other things. One powerful bonus also in this course, which is the metro station. A bonus HAP file will be provided for one of the metro stations that were recently created, not only providing the HAP file, but together we'll navigate across the HAP file to be obvious for you understanding it and how to utilize it. We'll navigate also across the architectural layout of the station, in addition to the 3D model, revealing the different HVAC systems and equipment. Last but not least, this course is expandable and more lessons to come. At the end, it's a risk-free course with money-back guarantee. I'll be extremely delighted to meet you in the course. Act now and see you there.